So can you guess, can you tell any outside nature, you can see that a photoelectric effect takes place. A light of suitable frequency falls on the metal surface, the electrons will come out. Example is solar cells, you know, right? Not solar cells, that solar panels. When light falls, what happens? Charges come out. That's why it will store the electricity. Understood? So different materials will take different light rays and they will give out electrons. For example, you see X-rays. X-rays when fall on some surfaces, electrons come out. When visible light also, UV rays, zinc plate, you take zinc or cadmium, anything. If the UV light rays falls on it, the electrons come out. This is what we call photoelectric emission. Understood? So photoelectric emission means a suitable frequency, right down, a suitable frequency of light ray, incident on the metal surface gives out electrons. This is what we call photoelectric emission. So example is cadmium, zinc, different you can take any copper also, it will give out electrons. Okay, it depends on the nature of the material. Well, how it is like that? Because you see, whenever you take any of the an atom you take, inside center atom nucleus will be there, electrons are revolving around the nucleus in the all different orbits, right? Correct, right? And outermost orbit, valence electrons will be there. They are very like, they are not very close to the nucleus. Nucleus is at the center. These outermost electrons are very far from the nuclear force, weak nuclear force. So they are valence electrons, weak electrons. So whenever a suitable energy of light ray fall on that substance, these electrons receive that energy, and by taking that energy, the charges come out. They will use this energy to come out from this weak nuclear force. Understood? So weak nuclear force, they will escape from that weak nuclear force and they come out. That is what we call photoelectric emission. This is what the topic of discussion today. I mean, in this chapter. Understood? What are the three ways? Understood? There is one more way, fourth way, that I will do. Secondary emission. What is this secondary emission? You know? What? What is the secondary emission?
Yes, if positive.
Whenever a light of suitable, not light, what I will do is, I will take a one material. Okay. I will hit that material with a strong electron from the outside, accelerating or a high velocity electron. That electron will come and hit the surface. Now what will happen? Whatever the electron it hit the surface, it will also come out with another electron pair. 2 electrons will come out. See, 1 electron brings 2 electrons. This is called secondary emission. What do we call? Secondary emission. You know, see why I said already, in center nucleus will be there, and all the electrons are revolving around the nucleus in different orbits. Now for example, this valence electron which is at the outermost orbit, whenever this is very free means the force of attraction, weak nuclear attraction will be less. Now whenever this strong electron hit this electron, both electrons just come out. This is what we call secondary emission. Understood? Secondary emission. Yes. So secondary emission means what? By injecting a secondary electron, a secondary strong electron secondary strong electron, we will get another material electron, another electron from the metal. It may be one or more, it may be more also. Not only one electron I am telling, it may be more also. This is what you call secondary emission. So 4 emission of electrons, you understood? Okay, what is the first one? Thermionic effect. Due to heat, if you apply heat on the substances, the electrons will come out. Next, field effect, field emission. What it will happen when you apply strong magnetic electric field actually, if you apply electric field, magnetic field it will not come out. Electric field if you apply, what will happen? The electrons may come out. The third one is photoelectric effects, photoelectric emission. Whenever a suitable frequency of light falls on the surface of the metal, now the electrons will come out. The fourth one is secondary effects. Okay, understood? Yes. Now please take the heading photoelectric emission. Yeah. So we are interested to study this photoelectric effects. Photo, yes, photo, okay, photoelectric effect. Actually, this is very interesting when you do this with Einstein's photoelectric equation. Einstein explained this effect, I mean photoelectric emission is very nice. Understood? Okay, so first we will start with basics. Wow, who first observed this photoelectric effect? It was observed by Hertz. Okay, photoelectric effect first was observed by Hertz. So what he did is, this Hertz is the first person. You know where you will use Hertz? Frequency unit is Hertz. Correct, right? This guy, Henrik Hertz. This Henrik Hertz, what he did is, he was in a lab, he was actually accelerating the charges. He was accelerating charges. Charges is accelerating. That accelerating charges producing X-rays. How we did is, he taken a metal plate. Okay, he was like applying some field or something. There are 4 we discussed. He applied even light, suitable frequency of light. What he observed is electrons are coming out. A high light he applied, okay, electrons are coming out. In some cases they say he applied a strong field, okay, there are electrons are coming like a sparks, sparks that he observed. That sparks are the sources of electromagnetic waves. So he is the first person who discovered who actually produced electromagnetic waves in the lab. Who? Hertz. Understood? So he says, okay, whenever a strong field or strong light falls on the metal surface, these sparks are coming out. These sparks are like electrons. These are electrons. Definitely, X-rays means this one, the electrons. Understood? X-rays means a strong X-rays means these strong electrons which come, that's why you see X-rays whenever they fall on the body, okay, they will go inside the body, but they will reflect on the bone. They will not move inside the bone. Bone is very strong. They will enter inside the skin. They will penetrate inside the skin, but they will reflect on the bone and they will come out. Understood? So they will penetrate from the bone. That's why this is called, these X-rays are so strong, energetic. That's why you're scanning, X-ray scanning, what you will see? What you will see? Your bones you will see. Correct, right? Why bones only you will see? Because they will penetrate only through skin. Bones they will reflect back. That's why you will see only bones. So whatever fracture happened you can find. Understood? So these are strong electrons. So this is first is the Hertz who observed this photoelectric effect. Understood? Now, shall I clean it? Yeah. Yes. Next, how this experimental arrangement, what is photoelectric effect, what is basically this Hallwatch and Reynolds observed, we will discuss now. First I will explain what is photoelectric effect by Einstein. Okay, then you can explain the photoelectric effect in Einstein, how he explains, then what is the experimental way of understanding photoelectric effect, everything. Okay, so first you see, I will just take experimental understanding of photoelectric effect, experimental observation. Yeah, experimental method. So what is experimental method? Take the two rods and metal plates. Okay, two metal plates you take. This is one metal plate. This is another metal plate. This metal plate name is cathode and this metal plate name is anode. This is emitter plate. Cathode plate is emitter plate. Emitter plate. And this anode plate is collector plate. What it is? Collector plate. Understood? Huh? Two plates are there. Which one is first one? Emitter plate. The second one is collector plate. Whenever a light rays of suitable frequency falls on this emitter plate, the energy of the incident light ray is E is equals to h mu. Some energy, strong light. It may be UV rays. It may be ultraviolet rays. Ultraviolet means UV rays. Correct, right? So, or visible light. When they fall on the emitter plate, okay, the electrons come out. For example, you take copper, it will work very well with UV rays. Okay, cadmium, zinc. Zinc is for visible light, I think. Yes. So the electrons just come out, and this collector plate will collect it. Understood? This emitter plates emits, and the collector plates will collect. Okay. So this is what we call photoelectric emission. Okay, so this experimental setup we will draw now. How it will be, just see. One quartz tube I will take. What I will take? One quartz tube. Yeah, this is a fine. Take one quartz tube. This is a tube. Then it will be like this. Okay. Okay. This is a quartz tube, and this is a quartz inlet where the light rays will come. And we will take two rods. This is one rod. This is another rod. This is cathode and this is anode. Now this is a window. From this window, which rays will come? Light rays. It may be any rays. Photoelectric rays, that UV rays, any rays. Any rays means, you see, it's not like, oh, any ray the metal plate will give electrons. No. For example, for a particular material nature, it depends. For example, if the material is very good of giving out electrons to visible light, then you should use that metal and that light rays. Understood? This quartz window, no? This quartz window will filter. This quartz window filter the light rays. They are applying in the quartz crystal. This quartz crystal, whichever light rays you want, it will filter. For example, you want visible light. Visible light is coming everywhere. You want UV rays, it will filter. X-rays, it will filter. That particular filtered quartz crystal they will put in the production. Understood? Understood? When the light ray falls here, okay, the light rays will come with some energy E is equals to h mu. See? Just they will fall. 1 minute. 1 minute. Please write this experiment, this diagram. This is the experimental setup
Einstein.
not Einstein, to study the photoelectric effect.
Done by Einstein.
It is done long before, not Einstein. Einstein gave any explanation. Okay. Light rays are falling to the cathode metal plate. This is emitter plate. It is emitter plate, and this one is collector plate, which is collector plate. Yeah. Now this is the quartz window, and this is emitter plate, which is cathode, plate, and this one is anode. Now you see what they did. These two metal plates, they are connected to a compiler. Okay. Please take this. Then I will explain about that compiler and all. Please take first.
Yes, sir.
Done now. Yeah. Okay. Anode and cathode done now. I will write one neatly actually. Listen here. This is not much neat. Okay. You see? Yes? This is, oh, please make it silent. Who is calling now? Hmm? Now you see, this is one metal plate, this is another metal plate, this is C and this is A. This is connected like this, okay, and this is connected like this. Now you see, very important, you see, this is going like this. Writing diagrams is difficult, huh? Easy for you, you know. Okay. Wait. Okay. Now here this they connected again to a battery. There is no space here. Huh? I am making it. No. Here it reads. First I will see what I will do. I will write down one. Then I will take right up. You just see. This is a battery here. Okay. Okay. This is plus. This is minus. Then connect here with resistor. Okay. Then here it is 1 voltmeter. Then here it is. Then here 2 voltmeter. Connect one current, microammeter. Okay. I will tell what is this. Okay. Now here yeah. Okay. Now here this is there connected, this is disconnected. Okay. Now this is connected to one plate, anode plate, and this is connected to cathode plate. Okay. From cathode plate again one more will come. Okay. This is there. This is there. Okay. Okay. Now you see here this entire tube is connected to the quartz tube. This is a quartz tube. This is a quartz window. This is collector plate and this is emitter plate. Now you see what will happen. This is emitter plate, this is collector plate, this is cathode and this is anode. Okay. Now I will not write cathode here. It will touch, it will go. Correct, right? It's very difficult here. This is C. Anyway, now you see this light rays whenever they fall from this quartz window. This is window. The light rays just fall. They'll just come and the electrons will come out like this. And this collector plates will collect. At that collector plates, whatever it will collect now, this is what we call compiler. Okay. So what will happen? This electrons it will collect, and electrons will send to this microammeter. This microammeter will check how much current is coming. Understood? Now why they connected battery? This battery will give the potential difference between these two plates. This is cathode plate and anode plate. It will give potential or electric field. Electric field it will give. For cathode plate it will give positive electric field, and for anode plate it is give negative electric field. Or otherwise, for cathode plate it will give negative electric field and anode plate it will give positive electric field. And this will operate the reverse. Both. Either in that way or in this way. Understood? Whatever I said now, this name is not compiler actually. Something is there, but I'm telling it's compiler. It's compiler means connecting, combining. So it's not combining. Okay, controller, something it is there, control. Now you see, this resistor is there, no? Here, when a light ray is falling on the metal surface, okay, electrons will come out. What this potential it will do? It will give negative electric field here. What it will do? Negative electric field here. If you give negative electric field, this metal plate is there, no? This cathode metal plate, okay, this is connected to a battery, right? If you give negative electric field here, what negative electric field will do? Electrons in the cathode metal plate will be repels. Correct, right? Negative electric field will not attract to the electrons. Electrons is negative charge. If you give negative electric field only, what will happen? These electrons will be repels. So that's why they will come out from this metal plate after falling this suitable light rays. These electrons will come out and they will fall on the anode metal plate where these electrons will be stored. Why? Because it is connected to the positive field. Positive field means what?
Sir, positive and required emission factor.
Yeah, no, not like that. Positive electric field means electrons will attract it to positive charge. Correct, right? Electron is a negative charge. It will try to attract to a positive charge. Now, the field which is connected is positive field. Positive field means definitely electrons will try to attract. That's why we are giving positive electric field there from the battery. Positive field if you give, electrons will attract. Negative if you give, electrons will be repelled. So that charges will move. Understood? This is the whole process. For example, if you want to make the electrons to slow down. What will happen? Just reverse this. This one will reverse the process. What will happen? This negative, instead of giving negative here, it will give there. Instead of giving positive here, it will give. Instead of giving positive there, it will give here. So that it will reverse, and also the photoelectric effect will be reduced. Understood? Okay, this is what the experimental arrangement of the photoelectric effect. Understood? So the brief explanation I will give in the next class.
Thanks.
Yes.